Just 39 light-years away, there is a star system unlike any other. A tiny red star, barely larger than Jupiter. So faint you'd never notice it with the naked eye. And yet, around that dim ember orbit 7 Earth-sized worlds. Packed so tightly together their entire solar system could fit inside Mercury's orbit. 7 worlds, each one a test of how easily life can begin. And one of them, a world where day and night never truly exist. This is TRAPPIST-1e. Welcome to Void Therapy. TRAPPIST-1 is a red dwarf star. That makes it much smaller, cooler, and dimmer than our Sun. If you stood on one of its planets at midday, the sky would not glow bright white. It would burn in deep red tones, like a world trapped in permanent sunset. Red dwarfs have something extraordinary. Our Sun will burn for about 10 billion years. TRAPPIST-1 could shine for trillions, long enough for evolution to attempt life not once, but countless times. The 7 planets of TRAPPIST-1 orbit so tightly that their entire system would fit well within Mercury's orbit around our Sun. TRAPPIST-1e, the 4th planet, completes a full orbit in just 6.1 Earth days. A year there lasts less than a week here. That kind of closeness changes everything. When a planet orbits that near to its star, gravity begins to reshape its behavior. Rotation slows. Over time, the planet locks into place. One side always faces the star. The other side never sees it. Permanent daylight. Permanent night. Which brings us to the defining question of TRAPPIST-1e. If one hemisphere is constantly heated and the other frozen in endless darkness, how could life possibly survive there? Tidal locking isn't a death sentence. It's a redistribution problem. If TRAPPIST-1e has a thick enough atmosphere, winds could circulate heat from the day side to the night side. And between eternal light and endless dark, a narrow ring emerges, a twilight belt, a global strip where temperatures might stabilize. Not an Earth-sized paradise, but a habitable band wrapped around a locked world like a thin necklace of pure life. And TRAPPIST-1e is particularly interesting because its density suggests it's rocky, not a gas planet, not an ocean world drowned in kilometers of water, solid, potentially capable of holding continents. But all of that depends on one fragile variable, an atmosphere. So here's the real tension. Did TRAPPIST-1e manage to keep its atmosphere, or did its star strip it away long ago? For the first time in human history, we can analyze the atmospheres of small, rocky planets around nearby stars. James Webb already looked at TRAPPIST-1b, one of the inner planets, and found little evidence of a thick CO2 atmosphere. But TRAPPIST-1e sits farther out, right in the habitable zone. And current JWST observations are attempting to determine whether it holds a secondary atmosphere, one built by volcanism, chemistry, and time. If it does, it could sustain surface liquid water. But let's say it does. Let's say TRAPPIST-1e has oceans and clouds and wind. Would that make it better than Earth? TRAPPIST-1 is around 7 to 8 billion years old, older than our Sun, which means TRAPPIST-1e may have had billions of extra years for its climate to stabilize and its chemistry to mature. On Earth, it took nearly 4 billion years for complex life to emerge. TRAPPIST-1e had more time than that. More time for oceans to settle. More time for atmosphere to regulate. Red dwarfs also brighten slowly over immense timescales. That means a planet in the habitable zone can remain there for billions of years without dramatic shifts. Longer windows of stability than Earth has ever known. On paper, that sounds better. Older system, longer lifespan, extended habitability. So the real question becomes, is TRAPPIST-1e a perfected version of Earth? We throw around the phrase Earth-like as if it is simple. Rocky planet, right temperature, water. But Earth is not simple. It has a magnetic field that shields it, plate tectonics that regulate carbon, a large moon that stabilizes its tilt. Remove one variable and climate shifts. Remove two and the surface becomes hostile. 7 Earth-sized planets orbit one small star. 3 sit in the habitable zone. Only 1 appears to balance mass, temperature, and distance with this level of precision. That is not abundance. That is improbability. And yes, life could exist there in some form. Microbial, atmospheric, hidden beneath oceans. But that is a different question. For now, the lesson is simpler. When we look 39 light-years away and search for a world that might be better than ours, what we are really discovering is how delicate our own world truly is. TRAPPIST-1e might be balanced on that same knife edge, and that does not make Earth less special. It makes it, statistically, miraculous. YouTube thinks you should watch this next. Until then, stay curious.